Hello there, and welcome to the Sleep with Science channel, where tonight, we are going to do something quietly extraordinary together. We are going to leave this world behind, not in the way of dreams exactly, but in the way of truth, in the way of the vast and humbling reality that exists just beyond the thin blue line of sky that holds us here, gently, the way a mother holds something fragile and irreplaceable, not wanting to let go but knowing, someday she must. Close your eyes if you haven't already. Let your body sink a little deeper into wherever you are right now. Your bed, your couch, the quiet dark of your room. Feel the weight of the day dissolving, slowly, the way stars dissolve into morning light, not all at once, but gradually, gracefully, one by one. There is nothing you need to carry right now. There is nowhere you need to be. There is only this voice, this silence beneath the voice, and the impossible, magnificent darkness of space waiting just outside the atmosphere above your head. Because tonight, we are going to travel somewhere no human being has ever truly been. We are going to trace the edge of humanity's most daring dream, a dream so enormous, so ancient in its longing, so terrifying in its honesty, that most of us feel it only in flashes, on clear nights when Mars hangs low and rust-red in the sky and something deep inside us stirs, something older than language, older than civilization, something that remembers what it felt like to look at the horizon and wonder what lay beyond it. Mars. Even the name carries a kind of gravity. 4 letters. 1 syllable. And yet inside those 4 letters lives an entire world. A world with mountains so tall they pierce the upper reaches of its own atmosphere, with canyons so deep and so wide that the entire continental United States could be set inside them and still not reach the walls. A world where the sun rises small and pale and cold, where the dust is the color of dried blood, where the silence is so profound and so absolute that it is a kind of sound all its own. 4 decades now, that world has been the direction of our reaching. Scientists have mapped it from orbit. Rovers have slowly crossed its ancient plains, their wheels pressing the first marks into soil that had never known a tire, never known a footprint, never known the weight of anything built by human hands. We have listened to the wind there, and yes, there is wind on Mars, thin and cold and whispering, rolling across plains that have been empty for billions of years. We have tasted the chemistry of its soil. We have studied the frozen water beneath its poles and inside its rocks, the remnant memory of rivers that once ran warm and wide across a world that may have, in another age, held something like life. And now, in laboratories and planning rooms and simulation chambers stretched across this planet, the next step is being drawn in careful, painstaking detail. Not rovers this time. Not satellites. Not robotic arms reaching gently into Martian soil. Human beings. Flesh and blood and bone. Heartbeats. Breath. Consciousness. The living, breathing, dreaming thing that we are, all of that, sealed inside a spacecraft, aimed at a point of light in the night sky, and sent across a distance so unimaginable that it requires a moment of real stillness to begin to take it in. On average, Mars is about 140 million miles from Earth. 140 million. If you were to drive there at highway speed, 65 miles per hour, windows down, music playing, without ever stopping for fuel, for sleep, for food, for any of the ordinary comforts of human life, the journey would take you approximately 246 years. Not months. Not decades. Centuries. Your great-great-great-great-great-grandchildren would still not have arrived. And yet a spacecraft, burning through the silence on precisely calculated trajectories, threading the orbital mathematics of 2 planets moving around the same sun at different speeds and different distances, can make that crossing in somewhere between 6 and 9 months, depending on when the journey begins, depending on the alignment of the worlds, depending on 100 variables that teams of brilliant people spend their entire careers refining and re-refining. 6 to 9 months. Inside a vessel. In the dark. In zero gravity, or near it. With a crew of human beings who will not be able to look out a window and see anything familiar. No blue marble slowly shrinking behind them after the first weeks, no rust-red destination growing reliably larger in front of them, just the fixed, cold, unblinking stars, the same in every direction, indifferent and eternal, and the knowledge that they are further from home than any human beings have ever been. Think about that for just a moment. Let it settle. Let it be as large as it actually is. Because this is not a movie. This is not a novel. This is a plan that exists in documents right now, in proposals and engineering blueprints and medical research papers, in the minds of people who are alive tonight on this same planet where you are lying down in the quiet dark. It is a plan being made by human beings, for human beings, fragile, extraordinary, irreplaceable human beings, and it is a plan that carries inside it a kind of beauty and a kind of terror so deeply intertwined that you cannot fully separate them. Not really, not if you are being honest with yourself in the way that only the quiet dark of late night allows. Because the truth about humanity's first trip to Mars is not a simple truth. It is not a clean, bright, triumphant headline waiting to be written. It is something older and stranger and more layered than that. A truth that lives at the intersection of our greatest courage and our deepest vulnerability, at the place where human ambition meets the cold, indifferent mathematics of the universe, and where the dream of becoming something more than we are brushes up against the very real, very sobering limits of what we are right now, in these bodies, on this journey, across this unthinkable distance. And so tonight, we are going to sit with that truth together. Slowly, gently, without rushing toward conclusions or resolutions, because the universe does not rush, and neither should we. We are going to let this story unfold the way space itself unfolds, in layers, in depth, in a silence so full it becomes its own kind of music, the kind that plays not in your ears but somewhere deeper, somewhere in the part of you that has always known, without being told, that the cosmos is larger than any word we have yet invented for it. Let your breathing slow a little more. Notice the rhythm of it, the inhale, the pause, the exhale. That rhythm is ancient. It has been with you since the first moments of your life, constant and faithful, and it will carry you through this night the way it has carried you through every night before it. There is something profound in that constancy, something worth noticing, especially when we are preparing to contemplate a journey during which every single breath will have to be manufactured, calculated, preserved, and protected with extraordinary, unrelenting care. On Mars, the atmosphere is roughly 1% the density of Earth's. 1%. The air you are breathing right now, this invisible, taken-for-granted gift of a living planet, would be essentially absent. A human being stepping onto the Martian surface without a pressurized suit would lose consciousness in seconds. Not because of the cold, though the cold is staggering, with average temperatures hovering around -80 degrees Fahrenheit and dropping far lower at the poles during the long Martian winter. Not because of the radiation, though the radiation is a serious and ever-present concern we will return to in time, but simply because there is almost nothing there to breathe. The Martian atmosphere is composed primarily of carbon dioxide, more than 95% of it, with trace amounts of nitrogen and argon and only the faintest whisper of oxygen, far too little to sustain the fragile biological machinery that keeps a human being alive and thinking and dreaming. And yet people are planning to go there. People are volunteering for this. People are training for this, studying for this, giving years and in some cases the better part of their lives to the preparation for this journey, knowing these facts, knowing them fully, sitting with them in the same quiet honesty we are sitting with them right now, and choosing, still, to say yes. To say forward. To say that the horizon, however dangerous, is worth walking toward. There is something in that choice that deserves to be held carefully, the way you might hold a very small, very bright flame, close enough to feel its warmth, carefully enough not to extinguish it. Because the decision to go to Mars is not made by people who do not understand the risks. It is made precisely by those who understand them most completely, who have spent the most hours staring into the data, reading the medical literature, running the simulations, asking every hard question there is to ask and sitting with the answers, however uncomfortable those answers might be. And then choosing, with full knowledge and full awareness, to go anyway. That quality, that clear-eyed, fully informed willingness to step into the unknown, is one of the oldest and most defining qualities of our species. It is the same quality that drove the first human beings to cross land bridges into unknown continents, following herds of animals into landscapes no member of their group had ever seen. It is the same quality that filled the sails of wooden boats pointed toward horizons that the maps of their time described only as emptiness. It is the same quality that climbed into small metal capsules balanced on towers of controlled explosive force and allowed themselves to be launched away from everything they had ever known, toward a gray and airless world hanging in the black sky above, because something in the human spirit does not accept the word impossible as a final answer. It accepts it only as a current condition, a temporary state, a problem waiting for a patient and creative enough mind to dissolve it. We are, at the cellular level, a species of boundary crossers. It is written into our history so completely that you cannot remove it without the whole story collapsing. Every continent we now call home was once unknown to the human beings who eventually reached it. Every ocean we now cross in hours was once a terrifying mystery, wide and unpredictable and full of dangers that could not be fully anticipated no matter how carefully the voyage was planned. And now the ocean is space. And the far shore is a small, red, rust-colored world slowly turning in the darkness, about 140 million miles away, where the wind moves through silence so deep and so ancient that it carries within it the memory of a world that existed long before the first single-celled creature stirred in the shallow seas of our own young Earth. A world that has been waiting, in its cold and patient way, for something to arrive and look at it with wondering eyes. And we are going to send people there. Human beings. Real ones. With names and families and memories and fears and hopes that have nothing to do with trajectory calculations or atmospheric pressure readings, hopes that are simply human, the hope to see something beautiful, the hope to come back home, the hope that the risk was worth it, that the story they became part of will mean something, not just to science, not just to history, but to the quiet, private interior of their own lives, the part that no mission briefing can fully reach. But before we can truly understand what that journey means, before we can hold it in the honest and careful way it deserves to be held, we need to understand something about the space between here and there. Not just the distance, though the distance is extraordinary. Not just the time, though the time is unlike anything a human being has ever endured in the name of exploration. We need to understand the quality of that space, the texture of it, what it actually is to exist inside it, sealed away from everything that life on Earth has always provided freely and without condition. Imagine, for a moment, that you could step outside your door tonight and simply begin walking upward. Past the rooftops, past the clouds gathering softly above the city or the countryside where you are. Past the place where the sky begins to deepen from blue into purple into the first true black of space, at around 62 miles above the surface, the boundary that scientists call the Kármán line, named for the Hungarian-American physicist Theodor von Kármán, who first calculated where Earth's atmosphere effectively ends and the vacuum of space begins. 62 miles. That is less than the distance many people drive to work in a week. And yet everything above that invisible line is another universe entirely, governed by different rules, offering different dangers, demanding a completely different relationship with the body and the mind and the ordinary assumptions about life that most of us carry without ever examining them. Above that line, there is no weather, no wind in the earthly sense, no rain, no pressure against your skin, no sound that can travel through the vacuum to reach your ears, because sound requires a medium, air, water, solid material, and space provides none of these things in the places between worlds. The silence of space is not the silence of a quiet room or a peaceful night. It is the silence of absolute absence, A silence so total that it would register not as peace, but as a kind of sensory deprivation so profound the mind would struggle to process it without careful preparation and psychological support. And temperature. Temperature in space is not the kind of thing that wraps around you gradually the way cold does on a winter night. In space, the concept of temperature behaves in ways that feel almost philosophical. In direct sunlight, the surface of a spacecraft can reach 250 degrees Fahrenheit. In shadow, just meters away, that same surface can plunge to negative 250 degrees. The swing between those two extremes can happen in minutes as a spacecraft crosses from the sunlit side of its orbit into shadow. The engineering required to manage those extremes, to keep the interior of a crewed spacecraft at a temperature that human bodies can tolerate consistently for months, is one of the most demanding and unforgiving challenges in the entire architecture of a Mars mission. And then there is radiation. This is perhaps the least visible and most quietly serious of all the challenges that deep space travel presents to the human body, and it is worth allowing some real stillness to settle around it, because it is the kind of challenge that does not announce itself with drama or urgency. It simply accumulates, the way certain truths accumulate, slowly and without fanfare, until one day you look up and realize how much has changed without your noticing. On Earth, we live inside a kind of invisible fortress. Our planet's magnetic field, generated by the churning of molten iron in the outer core deep beneath our feet, extends far out into space around us, deflecting the most energetic particles streaming constantly outward from the Sun. That stream of particles, called the solar wind, is not metaphorical. It is a real and ceaseless flow of protons and electrons and heavier ions, moving outward from the Sun in all directions at speeds of up to 900 kilometers per second. And beyond the solar wind, arriving from outside our solar system entirely, there is cosmic radiation, high-energy particles accelerated by distant supernovae and other violent events so far away that the light from the explosions that launched them has not yet reached us, may never reach us, may be traveling toward us still across distances that have no useful human equivalent. On Earth, the magnetic field and the atmosphere together reduce our exposure to this radiation to levels that our bodies, over billions of years of evolution, have learned to manage reasonably well. But a spacecraft traveling from Earth to Mars spends the vast majority of its journey outside the protective embrace of Earth's magnetic field, moving through open interplanetary space where that protection simply does not exist, where the full weight of the solar wind and the deep, ancient current of cosmic radiation falls upon the hull of the ship and everything inside it with a patience and a persistence that no amount of human ingenuity has yet found a complete answer to, though not for lack of trying, not for lack of the kind of careful, dedicated, sleepless effort that the best minds of our generation have poured into this problem with everything they have. The average radiation dose a person receives on Earth in a single year is roughly 3 millisieverts, a unit of measurement that most of us will never have reason to think about in our ordinary lives, but one that becomes deeply significant the moment you begin planning a journey through deep space. Astronauts living aboard the International Space Station, which orbits within the outer edges of Earth's protective magnetic field at an altitude of roughly 250 miles, receive a radiation dose of approximately 100 millisieverts over the course of a 6-month mission. Already that is more than 30 times what a person on the ground would receive in the same period. But a crew traveling to Mars, beyond the magnetic field shelter, moving through the open interplanetary medium for 6 to 9 months each way, could receive somewhere between 300 and 600 millisieverts over the course of the journey. And that estimate assumes no major solar events during the transit. No coronal mass ejections, those enormous eruptions of plasma and magnetic field from the Sun's surface that can dramatically spike radiation levels in the space between planets within hours, sometimes with very little warning. A significant solar particle event during a Mars transit could, in extreme cases, deliver a potentially lethal dose of radiation to an unshielded crew in a matter of days. This is not a theoretical concern pulled from the margins of speculative science fiction. It is a documented physical reality, one that mission planners think about with the kind of focused, unflinching seriousness that the stakes demand. And one of the most striking aspects of this challenge is how thoroughly it illustrates the central tension at the heart of everything we are exploring tonight, the tension between what we dream of doing and what the universe, in its vast and unhurried indifference, will allow us to do, and at what cost. Because the solutions being developed for radiation protection on a Mars mission are ingenious, genuinely, and yet each of them carries its own complications, its own weight. Shielding the crew compartment with water, which is an excellent absorber of certain types of radiation, is effective but enormously heavy, and every additional kilogram of mass on a Mars-bound spacecraft comes at an extraordinary cost in fuel and engineering complexity. Polyethylene, a type of plastic rich in hydrogen atoms, absorbs radiation more efficiently per unit of mass than most metals and has been studied seriously as a shielding material for deep space vehicles. Pharmaceutical approaches, drugs that might reduce the cellular damage caused by radiation exposure, are being researched and show some promise, though none yet approved for use offer complete protection. And storm shelters, small heavily shielded compartments within the spacecraft where the crew could take refuge during a solar particle event, represent perhaps the most practical near-term solution, a room within a room, a sanctuary within an already isolated vessel, the crew gathered close together in a small protected space while the sun exhales its fury against the hull outside. Think about that image for a moment. Let it sit with you in the quiet. A small group of human beings, the furthest from home that any of their kind has ever been, sealed inside a compartment within a compartment, listening perhaps to the systems around them, to each other's breathing, waiting for the radiation levels outside to subside, knowing that the nearest help is not hours away, not days away, but months away, separated from them not only by distance but by the irreducible speed of light itself, which means that even a radio message sent from that spacecraft to Earth might take anywhere from 3 minutes to 22 minutes to arrive, depending on where the two planets happen to be in their respective orbits around the Sun. 3 minutes at closest approach. 22 minutes when the planets are on opposite sides of the solar system. And the reply, if one comes immediately, takes equally as long to return. In a medical emergency, in any emergency, that communication delay transforms the nature of the crisis in ways that are difficult to fully appreciate until you sit with them quietly and let them become real. There is no calling for help in the way we understand calling for help. There is no voice on the other end of the line that can respond in real time. There is only the message sent into the dark, and the waiting, and the knowledge that whatever happens next must be handled by the people in that room, with the knowledge and the tools and the presence of mind they have carried with them from Earth, because there is nothing else available, nothing else possible, nothing else coming. This is one of the most profound psychological dimensions of a Mars mission, and it is one that receives perhaps less attention than the engineering challenges, less attention than the physiological ones, and yet it reaches into something so fundamentally human that it deserves to be approached with the same care and the same honesty. We are creatures of connection. We are wired, at a neurological level that goes deeper than culture or personality or individual preference, for the presence of others, for the knowledge that help exists somewhere within reach, that the community we belong to is accessible, that we are not truly alone. And Mars will ask those astronauts to become something that no human being has ever had to fully become before, to function, to think clearly, to make life or death decisions, to grieve if grief comes, to celebrate if celebration comes, to sustain the quiet daily rhythms of existence, all in the knowledge that the net of connection they have spent their entire lives inside of has been pulled away, gently but completely, and replaced with something thinner, something that carries warmth but cannot carry presence. There is a word that researchers who study long-duration spaceflight use often, and it is a word worth sitting with. The word is autonomy. Not in the political sense, not in the philosophical sense of free will, but in the operational sense, the degree to which a crew must function without external support, without real-time guidance, without the safety of deferred decisions. On the International Space Station, Autonomy is partial. Houston is always listening. A question asked in the morning receives an answer before noon. But on a Mars mission, autonomy becomes something closer to totality. The crew must become, in a very real and very demanding sense, their own mission control, their own medical team, their own engineers and geologists and navigators and counselors. They must carry not just their bodies and their tools into deep space, but the full architecture of human knowledge that any of those roles would ordinarily require. And this is not a hypothetical burden. The training programs that space agencies are developing for crewed Mars missions reflect this reality in their depth and in their seriousness. Crew members will need to perform surgical procedures with guidance transmitted across a delay measured not in seconds but in minutes. They will need to diagnose conditions, make pharmaceutical decisions, operate equipment in scenarios that no simulation can entirely replicate, because the body responds differently in reduced gravity, in elevated radiation environments, in the psychological pressure of isolation so complete it has no precedent in human experience. They will need to do all of this not once, not occasionally, but as a sustained practice across a mission that, from departure to return, will span somewhere between 2 and 3 years of continuous deep space travel. 2 to 3 years. Let that settle the way the dark settles at the edge of a fire. The Earth-Mars transit window, driven by the orbital mechanics of two planets moving at different speeds around the same sun, opens every 26 months. This is the synodic period of Mars, the interval between each moment when Earth and Mars return to the same relative positions. A crew launching at one window cannot simply choose to come home early if circumstances change, because the window will not reopen for more than 2 years. The orbital mathematics do not negotiate. They do not accommodate emergency returns the way a ship at sea might turn around, the way a polar expedition might arrange for early extraction. Once the trajectory is committed, the mission must be completed, or the crew must wait in place for conditions that may never be ideal, and return when the geometry of the solar system allows it. This is not a limitation of technology or funding or will. It is a constraint written into the structure of the cosmos itself, into the way planets move, into the laws that govern every body in the system, and it means that a Mars crew is committed, in a way that reaches far beyond what most professions demand, to the journey they have chosen. There is something quietly extraordinary about that. Something that belongs more to the age of wooden ships and unmapped oceans than to an era of instant communication and next-day delivery. And yet here we are, standing at the edge of that age again, about to send human beings into a silence that the ancient mariners would have recognized not in its physical details but in its essential emotional character, the character of separation, of no return possible, of horizon beyond horizon with no guarantee of what waits on the other side. The astronauts selected for these missions will carry this knowledge with them every day. It will be present in their morning routines, in the way they eat and sleep and exercise in a habitat that must sustain them with perfect reliability because there is no resupply mission close enough to matter, no emergency launch that could reach them before a crisis has already resolved itself one way or the other. The habitat itself, sealed, pressurized, warm against a cold that outside its walls would kill in seconds, becomes not just their home but the entire physical boundary of their world. Mars will be visible through a porthole, through a suit visor, through the extraordinary adventure of surface excursions that themselves carry risks enough to fill a separate conversation. But the habitat is the membrane between survival and the void, and its integrity is something the crew will monitor with an attention that never entirely relaxes, never fully allows the unconscious to stop listening for the sound that should not be there, the vibration that should not occur, the reading on a screen that drifts in the wrong direction in the small hours of what passes for night. And yet, and this is the part that deserves to be held alongside all the weight of what has come before, the people who are training for these missions are not doing so under compulsion. They are not resigned to this. They are drawn to it with something that looks, from the outside, very much like longing. A longing that is not naive, not uninformed, not the romantic dreaming of someone who has not looked carefully at the numbers or read the literature or sat with the silence of what this journey truly means. These are people who understand the risks more completely than perhaps anyone else alive, who have spent years learning precisely how hostile the environment of deep space is, precisely how fragile the human body becomes under its pressures, precisely how long the distances are and how final certain outcomes can be, and who have chosen, with full knowledge and open eyes, to want this anyway. To want it in the way that certain things are wanted not because they are comfortable or safe or certain, but because they feel, at some level beneath reason, necessary. True. Like the next sentence in a story that has been building for as long as our species has had the capacity to look up and wonder. That quality of longing has a history. It connects these astronauts, across all the distance of time and technology, to every human being who has ever stood at an edge and chosen to cross it. The ones who walked out of Africa into landscapes no member of their species had ever seen. The ones who built the first boats and pushed them into water that had no visible far shore. The ones who mapped the coastlines of continents, climbed the highest peaks, descended into ocean trenches where light does not reach and pressure becomes a physical force that the body must be armored against just to survive. The desire to go where no one has gone is not a modern invention. It is not a product of space programs or science fiction or national competition. It is something older than any of those things, something embedded in the pattern of what we are, something that has carried the species across every frontier it has ever encountered and will carry it, now, across the one that matters most. Because Mars is not simply the next destination. Mars is the first world that is not this one. Every other place human beings have traveled to, every mountain, every ocean, every polar ice field, every depth of cave or jungle or desert, has been a part of Earth, subject to Earth's gravity and Earth's atmosphere and Earth's biology, different in character but not in kind. Mars is different in kind. Mars is another planet. It formed from different material, evolved under different conditions, has a sky of a different color and a gravity that would feel, to a human body accustomed to this world, like walking in a dream. Roughly 38% of Earth's surface gravity. Enough to give weight, to orient the body, to allow the fluid systems that depend on the pull of a planet to function in something closer to their intended way, but not the same. Never the same. Every step on the Martian surface would be a step taken on ground that no member of our species has ever touched, under a sky that no human eye has ever seen directly, in silence that no human ear has ever heard, and the significance of that, the sheer, staggering significance of that, is the kind of thing the mind can approach in fragments but perhaps never fully contain. The surface of Mars is cold in a way that the word cold does not quite capture. Average temperatures hover around -60 degrees Celsius, though they vary enormously, from close to 20 degrees above freezing near the equator in summer afternoons, to nearly 150 below zero at the poles in winter. The atmosphere is thin, roughly 1% of Earth's atmospheric pressure at sea level, composed primarily of carbon dioxide with traces of nitrogen and argon and almost none of the oxygen that a human body requires. Without a suit, consciousness would last seconds. Without the careful engineering of pressure and temperature and air composition that a habitat and a suit together provide, Mars is not a place where human life is possible. It is a place where human life is carried, preserved inside shells of our own making, sustained by systems we have built because the planet itself offers nothing in that direction. And yet it is not empty. It is not featureless. It is not the bleak and barren wasteland that a simple recitation of its atmospheric statistics might suggest. Mars is a world of extraordinary geological complexity, of landscapes that would be, by any aesthetic measure, beautiful. The Valles Marineris, a canyon system that stretches nearly 4,000 kilometers across the surface, nearly 10 kilometers deep in places, wide enough that if it were placed on Earth it would span the entire continental United States, is a feature so vast that it cannot be seen in its entirety from any single point on the ground. You would have to rise above it, to view it from orbit, to begin to comprehend its scale. Olympus Mons, the largest volcano in the solar system, rises nearly 22 kilometers above the surrounding plain, so broad at its base that if you stood at its center you would not be able to see its edges. They would lie beyond the curve of the planet itself. These are not ordinary landscapes. They are landscapes that belong to a different category of experience, a category that the human nervous system has never had the opportunity to encounter, and the first crew to stand among them will be standing in the presence of something that will ask of them a response no human language has yet developed the vocabulary to fully express. There are words we reach for in moments like this: awe, wonder, reverence, humility, and they are not wrong words, they are honest words, but they are also words that were made by people who had never left this world, who built their meanings from experiences contained within a single planetary surface, and they may prove, in the end, to be approximations. Placeholders. The beginning of a vocabulary that will need to grow in directions we cannot yet anticipate, because the experiences that will demand it have not yet happened. The astronauts who first walk on Mars will return, if they return, as people who are in some essential way different from the people who left. Not broken, not diminished, but changed in the way that only genuine encounter with the genuinely new can change a person. There is a quality that explorers sometimes describe after returning from the far edges of the world, a kind of perceptual shift, a recalibration of scale, a sense that the ordinary world has become simultaneously smaller and more precious. Edmund Hillary wrote about it after Everest. The Apollo astronauts spoke of it after the Moon. Edgar Mitchell, returning from Fermaro, described a sudden and overwhelming awareness of connection, of the Earth hanging in the dark, small and luminous and alive, and the feeling that its smallness was not diminishing but clarifying, the way a single candle clarifies the darkness it lives inside. The Mars crews will carry something similar home with them, and it will be different, because they will have been farther, stayed longer, and crossed a threshold that the Moon, for all its beauty, did not represent in quite the same way. The Moon is close enough to feel like an extension of Earth. At its farthest, it sits roughly 400,000 kilometers away, a distance that light crosses in a little over a second, that a radio signal bridges in a heartbeat, that the Apollo missions crossed in 3 days of travel. The Moon is visible from Earth with the naked eye in enough detail that its Maria and Highlands are familiar shapes, named and mapped for centuries before any human ever left the atmosphere. It is ours, in a way that feels instinctive. Mars is not ours in that way. Mars is a separate world, and the distance between this world and that one, even at closest approach, is not a distance the nervous system can be gently eased into. It must simply be crossed, held inside the body and the mind as a fact that is accepted even when it cannot be fully absorbed, the way certain truths about the universe must be accepted before they can be felt. And during that crossing, during those 7 months of interplanetary transit, the crew will have time. More time than any previous mission has offered. Time that will need to be structured carefully, because unstructured time in a confined and isolated environment is not simply boredom, it is a psychological pressure that compounds, that finds the edges of a person's resilience and tests them in ways that are subtle at first and less subtle over weeks and months. The research drawn from Antarctic winter-over studies, from submarine deployments, from the simulated isolation experiments that space agencies have run in sealed habitats with volunteer crews, all points in the same direction. The third quarter of any long isolated mission is the hardest. Not the beginning, when novelty and adrenaline sustain engagement. Not the end, when the destination becomes visible and forward momentum returns. The middle, the long, featureless middle, where neither origin nor destination feels close, where the mission has become routine without becoming comfortable, where the crew has been together long enough for every friction to have been discovered and none of them fully resolved. That is where the interior work becomes most demanding. Mission planners have known this for decades. The countermeasures they have developed are thoughtful and evidence-based, structured schedules, meaningful work, regular communication windows with Earth, private psychological support, carefully curated entertainment and cultural content, celebrations of small milestones, the preservation of as much personal space and autonomy as the physical constraints of the habitat allow. These are not trivial interventions. They reflect a genuine and evolving science of human performance in extreme environments, a science that has grown significantly in sophistication over the past 50 years and will need to grow further still before the first crew departs. Because the duration of a Mars mission exceeds anything that the existing database of long-duration spaceflight experience was gathered from. The longest continuous human presence in space, Valery Polyakov's record 437 days aboard Mir, approaches the transit time alone, without accounting for the surface operations or the return journey. The full mission will demand more, in every dimension, than any mission that has come before it. And the radiation. This is the word that sits at the back of every conversation about human Mars exploration with a quiet and persistent weight. The consideration that no amount of enthusiasm or engineering ingenuity or psychological preparation can entirely resolve with the tools currently available, the challenge that may, more than any other single factor, determine the shape of how this mission is ultimately designed and when it ultimately flies. The space between planets is not empty. It is filled with particles and energy that the Earth, in her extraordinary generosity, has always shielded us from without our asking, without our noticing, without our ever needing to think about the protection being offered. The magnetosphere, that vast invisible architecture of magnetic field lines generated by the churning of molten iron in the Earth's outer core, deflects the solar wind, redirects the charged particles streaming outward from the Sun, and creates around this planet a kind of sanctuary, a bubble of relative calm inside which life has been able to evolve and persist for billions of years without developing any particular defense against the radiation that exists just beyond its boundary. We have never needed that defense. The Earth provided it. And so we carry none of it with us when we leave. In low Earth orbit, where the International Space Station traces its path at roughly 400 kilometers altitude, the magnetosphere still offers partial protection. The station sits within the outer edges of that magnetic embrace, and while radiation levels there are meaningfully higher than on the surface, enough that astronaut health is carefully monitored, enough that long-duration crew members accumulate doses that are tracked against lifetime exposure limits, the fundamental architecture of protection still exists in some diminished form. Beyond it, in the space between worlds, that architecture disappears entirely. The crews of the Apollo missions experienced this during their transits to and from the Moon, and the data from those brief crossings, the longest lasted about 12 days in deep space, provided early measurements of the radiation environment that exists outside the magnetosphere's reach. What those measurements showed was sobering, and the transit time for a Mars mission is not 12 days. It is 210. Each way. The primary sources of radiation in interplanetary space are two. The first is the Sun itself, the constant outflow of solar wind, a stream of charged particles, mostly protons and electrons, that flows outward from the solar corona at speeds of hundreds of kilometers per second, and the more intense and unpredictable bursts of energy released during solar flares and coronal mass ejections. These events can increase radiation levels dramatically over the course of hours, and while they can be partially anticipated through solar weather monitoring, they cannot be predicted with the precision that a crew in deep space would need to act on them with complete confidence. A coronal mass ejection reaching a spacecraft in transit between planets could deliver, in a matter of hours, a radiation dose sufficient to cause acute radiation sickness, nausea, fatigue, cellular damage, the disruption of systems in the body that divide rapidly and are therefore most vulnerable to ionizing radiation. The crew would need shielding, a dedicated shelter within the habitat, lined with materials dense enough to absorb the worst of the particle flux, where they could retreat when the solar weather instruments gave sufficient warning. The second source is older and stranger and in many ways more difficult to address. Galactic cosmic rays are not particles from our Sun. They are particles from beyond our solar system, from supernovae, from the violent deaths of massive stars, from the energetic processes occurring in the cores of other galaxies entirely. They travel at fractions of the speed of light, carrying energies so high that conventional shielding struggles to stop them. In fact, certain materials that are effective against solar particle events can make galactic cosmic ray exposure worse, because when a high-energy cosmic ray strikes a dense nucleus, it can produce a shower of secondary particles that carries more combined energy than the original. The physics of shielding against galactic cosmic rays is not simply a matter of adding more material between the crew and the source. It is a problem of a different character, one that researchers are working on with approaches that include magnetic shielding concepts, water walls, polyethylene, a hydrogen-rich material that performs relatively well against certain particle types, and mission architecture choices that minimize total transit time, because time in deep space is time of exposure, and the most reliable way to reduce accumulated dose is to make the journey as swift as the physics of orbital mechanics allows. The data gathered by NASA's Curiosity rover during its transit to Mars, using the Radiation Assessment Detector instrument specifically designed to measure the deep space radiation environment, gave mission planners their first comprehensive picture of what a crew would actually face. The numbers confirmed what models had suggested, that a round trip to Mars, accounting for transit and surface time, would expose crew members to radiation doses significantly above the career limits currently set for astronauts operating in low Earth orbit. Not immediately lethal. Not the kind of exposure that ends a mission in crisis. But cumulative. Biological. Real in the way that probability becomes real when you sit quietly with it. An elevated lifetime risk of cancer, a potential for damage to the central nervous system that may affect cognition and memory in ways that are still being understood, a shortening, in statistical terms, of the years that wait on the other side of return. This is the honesty that the mission demands. Not to dwell in it, not to let it become the entire story, but to look at it clearly and directly the way one looks at any true thing, because the people who will make this journey deserve to have it looked at clearly, and the rest of us, following from Earth across those minutes of silence, deserve to understand what we are asking of them. What we are asking of them is something that has no clean precedent in the human story. Not war, though war asks terrible things. Not exploration in the classical sense, though this is exploration taken to its most extreme and luminous expression. What we are asking of them is the willingness to become, for a span of months and then years, genuinely unreachable. To cross a threshold of distance that transforms the very nature of human relationship, not metaphorically, not poetically, but in the hard physical grammar of light and time and the speed at which information is permitted to travel across the universe. There is a word that mission planners use when they speak of this condition. They call it communication latency. And the word latency sounds almost gentle, almost administrative, the kind of word that belongs in a software manual or a network engineering report. But what it describes, at its fullest depth, is something far more tender and far more strange. At its closest approach, Mars sits approximately 3 light minutes from Earth. At its farthest, more than 20. Which means that on the day a crew member aboard the first Mars habitat wakes with something wrong, a pain that shouldn't be there, a question that demands an answer, a fear moving quietly beneath the surface of a normal morning, the soonest they can hear a human voice responding from the world they left behind is 6 minutes. And on a bad orbital day, closer to 40. This is the isolation that has never been lived before. Not by the Apollo crews, who were 3 light seconds from home, who could hold something close to a conversation with mission control, who knew that in an emergency the round trip of a human voice required only a breath of waiting. The Mars crew will have no such luxury. They will make decisions in real time, with information that is already minutes old by the time it arrives, with medical advice that was formulated in response to a condition that may have already changed by the time the response lands. They will conduct their lives inside a latency that stretches long enough to read a chapter, to brew a cup of tea, to sit at a window and watch the rust-colored land in silence and then return and find the answer waiting. Mission architects describe this as the need for crew autonomy, for decision-making capacity that does not depend on Earth's approval, for a psychological resilience that can hold the weight of genuine independence without fracturing under it. The astronauts selected for the first Mars mission will not simply be scientists and pilots and engineers, though they will be all of those things to a degree of mastery that is difficult to fully comprehend. They will also be, in some deep and quiet sense, self-sufficient human beings in a way that the modern world has nearly forgotten how to produce. People who can sit with uncertainty and not be undone by it. Who can lose contact, as the mission will during solar conjunction, when Mars passes behind the Sun and radio silence becomes total for weeks at a stretch, and continue to function, to think, to care for one another and for themselves, in the full knowledge that they are beyond the reach of any voice they have ever loved. The psychological literature on isolated and confined environments is careful and extensive, built from decades of Antarctic winter-over studies, from submarine deployments, from the isolated simulation missions conducted in places like the Hawaii Space Exploration Analog, where small crews lived for months in domed habitats on volcanic slopes pretending, as convincingly as science could arrange, that the world outside was Mars. What the research finds, consistently, is that human beings can endure extraordinary isolation, but that the quality of what they endure depends enormously on the architecture of the relationships inside the confined space. Conflict in isolation does not dissipate the way conflict does in the open world, where you can walk away, where distance itself offers cooling. In a habitat the size of a modest apartment, shared with 4 or 5 other human beings for 600 days or more, disagreement has nowhere to go. Tension folds back into the space. It becomes part of the air. And so the selection of a crew for Mars is not only a technical exercise. It is, in some sense, an act of profound social engineering, an attempt to assemble a small group of people whose temperaments and values and tolerances and humor are calibrated to survive not just the radiation and the distance and the physical demands of the surface, but each other. The person who will walk on Mars must be exceptional in the ways we traditionally celebrate, brilliant, capable, trained to a fine edge, and also exceptional in ways we rarely think to celebrate. Emotionally regulated, genuinely curious about other people, capable of apology, capable of patience that extends across months and not merely moments. They will need to be, in the old and honest sense of the word, good. Good the way a person is good when no one is watching and there is nothing to gain from it, because on Mars there will be no audience and there will be nothing to gain from performance. Only the small, daily, unglamorous practice of treating the people beside you with care, because the people beside you are, for a very long time, the only people in the universe close enough to matter, close enough to notice, close enough to catch you when the particular loneliness of that place, and it will have its own particular loneliness, unlike anything that has been felt before, settles into the spaces between tasks and reminds you, quietly and without malice, that you are farther from home than any human being has ever been. And the land itself will remind you. Mars does not offer the consolations that Earth offers in its wild places. There is no birdsong in the thin, cold air. No scent of rain approaching across a distant hillside. No sound at all, in the way that sound is understood by a body that evolved inside the dense acoustic world of a living planet. The atmosphere of Mars, that tenuous veil of carbon dioxide roughly 1% as thick as Earth's, transmits sound so poorly that standing on the surface you would hear your own heartbeat more clearly than the wind. The Perseverance rover, equipped with microphones in a small act of poetic engineering, returned to us the actual sound of a Martian afternoon, and what it captured was a silence so profound and so alien that scientists described it as eerie. A quiet with a different texture than any quiet on Earth. The quiet of a place that has been without life for so long that it no longer holds even the memory of noise. This is the landscape into which human feet will one day press their first careful prints. And it is worth sitting with that image for a moment, not rushing past it toward the logistics and the timelines, but simply allowing it to be what it is. A human being, standing on the surface of another world. The suit pressurized to sustain a body that was never meant to exist there. The visor catching the pale, butterscotch light of a sun that hangs smaller in that sky than we have ever seen it. The ground beneath the boots a cold and ancient rust, mineral and dry, composed of iron oxides that give Mars its color and its name in the mythologies of a species that watched it move across the night sky for thousands of years before ever dreaming they might reach it. The gravity on the surface of Mars is approximately 38% of what a human body knows on Earth, which means the first crew member to step outside will feel, in a way that no simulation can fully replicate, simultaneously lighter and stranger. Movement will require recalibration. The body will miscalculate distances, misjudge the effort required to lift and carry, relearn in real time the basic grammar of physical existence in a gravity well that is weaker but still present, still insistent, still pulling at the bones in ways that after months in microgravity will themselves have changed. The skeleton that arrives on Mars will not be the same skeleton that departed Earth. Bone density lost in transit. Muscle adapted to weightlessness. A body in the continuous, quiet process of becoming something slightly other than what it was. And yet it will stand there, on Mars, looking out across a horizon that curves a little more sharply than Earth's, because Mars is a smaller world, and the mathematics of curvature are different there. Looking out across plains that in certain lights resemble the American Southwest, Utah, perhaps, or the high desert of New Mexico, and in other lights resemble nothing that exists anywhere in the long inventory of terrestrial landscapes. Valleys that make the Grand Canyon look modest. Olympus Mons rising at the edge of perception, a volcano so vast that its base would cover France and its summit pierces the upper limits of the Martian atmosphere. A mountain so large that standing at its base you would not know you were on a mountain at all, because the slope is so gradual and the scale so enormous that it simply reads, to human eyes calibrated for human scales, as a gentle upward tilt of the horizon. The surface of Mars holds geology in a kind of suspended eloquence. Without plate tectonics, without the constant rewriting that Earth performs on its own face through subduction and collision and volcanic renewal, the Martian terrain preserves its history in ways that Earth long ago erased. Ancient river channels carved by water that flowed more than 3 billion years ago are still visible from orbit, their shapes intact, tracing the memory of a time when Mars was warmer and wetter and perhaps, in some quiet corner of scientific possibility that has not yet been closed, not entirely without the conditions that life requires. The question of whether Mars was ever alive, whether microbial existence once stirred in those ancient waters before the magnetic field weakened and the atmosphere bled away into space, remains genuinely open, genuinely unanswered. And the first crew to walk that surface will carry with them instruments designed specifically to look for the traces of that possibility. Biosignatures, chemical imbalances, isotopic ratios that whisper of processes that chemistry alone cannot explain. This is perhaps the deepest question that the mission carries. Deeper than the engineering. Deeper than the radiation budgets and the communication protocols and the psychological screening and the years of preparation that stack behind this moment like a long and patient tide. The deepest question is whether, when those boots press into that ancient and mineral silence, the world beneath them was ever, in any form, in any era, in any fleeting and improbable arrangement of chemistry and water and time, home to something that could be called alive. Because the answer to that question does not merely satisfy scientific curiosity. It restructures, at the most fundamental level, the way humanity understands its own position in the universe. It changes the story we tell about what life is, whether it is a singular accident, a once-only flowering in the long cold darkness, or whether it is something more like a tendency, a property of matter itself, given the right conditions and sufficient time. An inclination of the universe toward complexity and self-organization that expresses itself wherever the temperature is gentle enough and the water present enough and the chemistry permissive enough to allow it. If Mars was alive, even once, even briefly, even at the scale of a single-celled organism threading its way through a warm and shallow Noachian sea 3.5 billion years ago, then life is not a miracle in the theological sense. It is a process, reproducible, distributed across the cosmos in ways we have not yet begun to map. And the loneliness of the universe, that vast and pressing quiet that has surrounded human consciousness since the first human being looked up and wondered, would be revealed as something other than what it appeared. Not emptiness, not abandonment, but a silence that was never total. A darkness in which, here and there, light had been finding its own way for longer than we knew. This is what the crew will carry in the back of every waking hour on that surface. Not as a burden, not as an abstraction, but as a living question that the ground beneath their feet may be on the verge of answering. Every sample collected and sealed into its sterile container. Every drill pressed into the sedimentary record of an ancient lakebed. Every measurement taken by instruments so sensitive they can detect the chemical signatures of biological processes at concentrations too faint to see, too faint to smell, detectable only as a deviation in a number on a screen that a scientist on Earth will spend weeks interpreting. Each of these small acts is a form of listening, a pressing of the human ear against the door of a room that may have once held life, that may hold its remnants still, preserved in the cold and arid and radiation-scoured rock like a message left so long ago that the language has to be reconstructed from first principles. The Jezero crater, where Perseverance currently rests and works and listens in its patient robotic way, was chosen precisely because orbital data suggested it once held a lake. That the delta visible from space, that fan-shaped deposit of sediment at the crater's western edge, was laid down by a river that flowed into standing water perhaps 3.5 billion years ago. Sedimentary deltas on Earth are among the most productive environments for the preservation of biosignatures. Life that existed in the water finds its way into the sediment. The sediment compresses over time into rock. The rock holds the record. And so Jezero is, in the most careful and scientifically grounded sense, a place chosen because it is among the most likely locations on Mars to have preserved evidence of ancient life, if ancient life existed. The choice was not poetic. It was probabilistic. And yet it carries a poetry so enormous that it becomes difficult to hold in the mind all at once, that human beings sent a machine the size of a car to an ancient lakebed on another planet specifically to look for the ghost of something alive. And Perseverance has been finding things. Not life. Not yet. Not the smoking gun that would rewrite every textbook and send the news across the planet in a wave of disbelief and wonder. But organic molecules. Carbon-bearing compounds that on Earth are associated with biological processes, though they can also arise through purely chemical means. And carbonate minerals in the rocks near the delta, consistent with formation in liquid water. And textures and structures that some scientists, speaking carefully and with appropriate qualification, describe as potentially consistent with microbial mats, the thin biological films that ancient life on Earth left pressed into shallow seafloor sediments like signatures in wet clay. None of this is confirmation. All of it is signal, faint and requiring interpretation, requiring the kind of patience that science demands and that the human mind, hungry for resolution, sometimes finds excruciating. The samples that Perseverance has been sealing into small titanium tubes and depositing at carefully mapped locations on the crater floor are waiting. Waiting for the sample return mission that will one day collect them and carry them back to Earth, where laboratories will subject them to analysis far beyond what any rover instrument can perform. Those tubes, sitting in the cold Martian dark, represent perhaps the most consequential cargo in the history of scientific exploration. Not because we know what they contain, but because of the range of what they might contain, the width of that possibility, stretching from nothing of biological significance to something that changes everything. They sit there across the silence of 60 million miles, patient in the way that only inanimate objects can be patient, waiting for the hands that will one day come for them, waiting with the indifference of matter and the patience of geological time for a human being to kneel in that rust-colored dust and lift them carefully and know that what is held in those small sealed cylinders may be the most important thing ever carried by a human hand. There is something about that image, the kneeling, the lifting, the weight of consequence held in something so small, that returns again and again when the mind tries to locate the emotional center of this mission. Because for all the engineering magnificence, for all the orbital mechanics and the radiation shielding and the psychological screening and the years of preparation compressing into the long, quiet fact of transit, what the mission finally comes down to is this: a person, a hand, a question. The oldest question that consciousness has ever carried, dressed now in the language of astrobiology and isotopic analysis, but identical at its root to the question that the first human being asked when they looked up at the night sky and felt the strange vertiginous awareness that the darkness above them was not a ceiling but a depth. Are we alone? Not alone in the social sense, not alone in the room, but alone in the way that matters most to a species aware enough to wonder whether its own awareness is unique in the universe. The scientists who have spent their careers preparing for this possibility speak about it with a particular quality of restraint. A careful, almost reverent calibration of language that reflects how completely they understand the weight of premature announcement. The history of Mars exploration contains within it a cautionary episode that every astrobiologist carries like a scar. In 1996, a team of NASA scientists announced that a Martian meteorite designated ALH-84001, recovered from the Allen Hills ice field in Antarctica, contained what appeared to be evidence of ancient Martian microbial life, microscopic tube-like structures, organic compounds, magnetite crystals of a type associated with bacterial processes on Earth. The announcement was made at the highest levels. The President of the United States spoke of it from the Rose Garden. And then, slowly, painstakingly, over the years that followed, the scientific community examined each line of evidence and offered alternative explanations: abiotic processes, terrestrial contamination, chemical mimicry, until the consensus settled not into confirmation but into ambiguity. The structures remained unexplained. The question remained open. But the certainty evaporated, and with it went a particular quality of public attention that has never quite returned in the same form. This is why the scientists who work at the edge of this question are so careful. Why the language of their papers is threaded with qualifications and conditional clauses and phrases like consistent with and potentially indicative of and cannot be ruled out. Not because they are timid, not because the question does not electrify them in ways they struggle to contain, but because they understand that the cost of a false positive in this particular inquiry is not merely professional embarrassment. It is the erosion of a kind of trust, the public's trust in the process of science at the very moment when that trust is needed most. When the answer, if it comes, will need to be believed by a civilization that has spent decades wondering whether it will ever arrive. And so the samples wait. And the mission is planned. And somewhere in the present moment, in offices and laboratories and simulation habitats scattered across several continents, the people who will one day make this journey are going about the ordinary texture of their extraordinary preparation. Running on treadmills inside vacuum-sealed facilities to understand how exercise physiology changes in altered pressure environments. Practicing surgical procedures in conditions designed to mimic the limited dexterity of pressurized gloves. Learning geology with the specific vocabulary of Mars, the names of the epochs, Noachian and Hesperian and Amazonian, each representing vast spans of planetary history defined by the nature of the surface processes that characterize them. Learning to read a landscape that no human eye has ever read before, in person, in real light, with the full sensory apparatus of a living body present and attending. They are learning, Also, how to be small inside something large. How to hold the knowledge of their own position. This speck of pressurized warmth moving through a darkness so vast it defeats ordinary imagination, without being defeated by it. This is perhaps the least visible part of the training, and perhaps the most essential. The philosophical preparation. The cultivation of what the psychologists call meaning-making, the human capacity to locate purpose and coherence inside conditions of radical uncertainty and profound isolation. The crew that departs for Mars will need to have made their peace with the fact that the journey itself is the thing. Not the destination, not the return, not the headlines waiting on the other side of the long transit home, but the daily, incremental, unglamorous reality of doing the work in the place where the work must be done. There is a quality of attention that extreme environments seem to cultivate in the people who survive them well. Antarctic expeditioners speak of it. Long-duration submariners describe something similar. A sharpening of presence, a narrowing of concern to what is immediate and real and within reach, that paradoxically opens into something larger. A sensitivity to small beauty, to the texture of routine, to the profound adequacy of a shared meal and a quiet hour and the sound of another person breathing in the darkness of a habitat that is, for now, the whole of the world. There is a word that keeps returning in the journals of those who have lived closest to the edge of human reach. Not a scientific word, not a technical one, but something older and quieter. The word is enough. It appears in Antarctic diaries written by lamplight at the bottom of winter. It surfaces in the recorded thoughts of cosmonauts floating above a planet they can cover with their thumb. Enough. Not in the sense of resignation, not the enough of someone who has stopped wanting more, but the enough of someone who has arrived, finally and without fanfare, at the present moment and found it sufficient. Found it, against all prior expectation, genuinely and completely full. The crew traveling to Mars will live inside that word for the better part of 3 years. They will learn it not as a concept but as a practice, the way one learns to breathe at altitude, through repetition, through failure, through the slow recalibration of what the body and the mind regard as normal. There will be mornings. If the word morning still applies in a place where the sun has shrunk to a particularly bright star and the light cycling through the habitat windows is artificial and deliberate, when the distance will feel not merely physical but ontological, as though the self has been somehow redistributed, as though some portion of what one has always assumed to be fixed and interior has been left behind in the orbit of the world that made them. Psychologists who study long-duration spaceflight describe a phenomenon they call the third quarter effect. It is not unique to space. Polar expeditioners know it. Transoceanic sailors know it. The point in a long journey where the initial excitement has long since dissolved and the end remains too far to serve as a genuine comfort. The middle distance of a hard thing. This is the place where resolve is not summoned once but must be summoned daily, quietly, without ceremony. Where the work of persisting is identical, on the outside, to every other day's work and yet internally requires something closer to an act of will than a habit of routine. The mission architects know this. The psychologists embedded in the training programs know this. And so the preparation goes deeper than checklists and emergency protocols, deeper than the technical rehearsal of docking maneuvers and life support diagnostics. It goes into the softer machinery, the question of what a person holds on to when everything familiar has been placed at an untouchable distance. What constitutes the self when the self is suspended between two worlds, belonging fully to neither? There are, it turns out, anchors. Small ones, humble ones, the kind that would seem almost embarrassingly mundane in any other context. A particular piece of music carried from home. The smell of something real, coffee, if the mission allows for it, or the slightly metallic warmth of a beverage that approximates it. The ritual of writing, even to no one in particular, even knowing the signal delay means that any response will arrive in the future tense, will arrive as an artifact of what was, by the time it lands, already the past. The practice of marking time not just on instruments but in small personal ceremonies, the way sailors once noted the passage of days by the accumulation of tallies scratched into wood. These things matter. More than mission planners in the early decades of spaceflight thought they would matter. The human animal, it turns out, requires continuity. Requires the sense that the life being lived in the extraordinary place is still, in some recognizable way, the same life. That the person doing the extraordinary thing is still, beneath the suit and the training and the mission designation, the person they have always been. This is not a weakness. It is the mechanism by which the mind protects its own coherence across the abyss. And the abyss, by the time the crew reaches the midpoint of their transit, will have become familiar in the way that all sustained presences eventually become familiar. The stars will have stopped being remarkable and started being ordinary, which is itself a remarkable thing. The human eye habituates. The human mind categorizes. The thing that was once incomprehensible becomes the background against which the comprehensible moves and breathes and is attended to. This is how the crew will survive the transit. Not by remaining in a state of continuous wonder, which is exhausting and unsustainable, but by achieving something quieter and more durable, a settled relationship with the scale of what surrounds them. There is a physics to the journey that corresponds, in its own way, to this interior geography. The spacecraft, once it has left the gravitational influence of Earth and has not yet entered the gravitational influence of Mars, exists in a condition called interplanetary space, a region defined less by what it contains than by what it is between. The sun's solar wind still reaches here, a thin and invisible rain of charged particles that the spacecraft's shielding deflects with constant and silent vigilance. The cosmic radiation that filters through from outside the solar system arrives here too, and the crew's exposure to it is one of the genuine and unsolved challenges of the mission. Not a danger that can be eliminated, only managed, only weighed against the magnitude of what the journey represents, and accepted as part of the price of the passage. The body accumulates this exposure the way a long life accumulates its losses, not all at once, not catastrophically, but steadily, invisibly, in the deep tissue of things that cannot quite be seen and cannot quite be undone. And yet the crew goes. This is the fact that returns, again and again, when one sits with the full weight of what the mission represents. Not the engineering, not the trajectory calculations, not the geopolitical architecture of funding and international cooperation that made the launch possible, but the simpler and more fundamental fact that human beings chose to go. That somewhere inside the elaborate structure of training and preparation and mission design, there is a core of pure voluntary motion. A yes that was spoken freely, in the full knowledge of what the yes entailed. The history of exploration is threaded with these moments. They do not always look heroic in the ordinary sense of the word. They do not always arrive with clarity or certainty or the clean confidence that the popular imagination tends to assign them. More often they arrive quietly, in the middle of an ordinary day, as a recognition rather than a decision, the understanding that this is the thing, that this is the direction the life has been moving toward, that to refuse it would be to refuse something essential in the self. The men and women who crossed oceans in wooden ships knew this feeling. The first climbers to stand at the base of the world's highest peaks and look upward knew it. It is not the absence of fear. It is something that exists alongside fear, that does not require fear's elimination in order to function. The crew that travels to Mars will carry this with them. Not as a memory, exactly, but as a quality of presence, the accumulated weight of having chosen, freely and repeatedly, to continue. Because the yes is not spoken once. It is spoken at every juncture where turning back remains possible. In the early months of training, when the difficulty of what lies ahead first becomes concrete rather than abstract. In the final weeks before departure, when the world that is being left behind becomes suddenly and painfully vivid. In the moment of launch itself, when the decision passes from the domain of the reversible into the domain of the actual. And then again, quietly, in every ordinary day of the transit, when the work is done and the habitat is still and the darkness outside is absolute and the mind, left briefly without a task, turns toward everything it has accepted and accepts it again. There is a concept in psychology called post-traumatic growth. It describes the phenomenon by which certain individuals, having passed through experiences of profound difficulty, emerge not merely intact but genuinely expanded, carrying new capacities, new perspectives, new relationships to meaning and mortality and the texture of daily life that they could not have arrived at by any less demanding route. The researchers who study this phenomenon are careful to distinguish it from resilience, which is the capacity to return to a prior state. Growth implies movement. It implies the development of something that was not there before. Something that the difficult experience did not merely permit, but actually produced. The Mars crew will be changed by what they do. The mission planners know this, and they regard it not as a side effect but as an outcome, perhaps one of the most significant outcomes of the entire endeavor. Because the people who return from Mars will carry knowledge that cannot be transmitted in any other way. Not knowledge about the planet's geology or atmospheric chemistry or the particular quality of its silence, though they will carry all of this too, but knowledge about the human capacity for sustained presence in conditions that exceed everything the species has previously asked of itself. Knowledge that lives in the body. Knowledge that changes the way a person looks at a room, at a window, at the face of someone they love. The planet they are traveling toward has its own knowledge to offer. Mars is not an empty place, though it is a profoundly still one. Its surface preserves, in the patient language of geology, a record of processes that unfolded across timescales that make human history appear not merely brief but almost imperceptibly thin. The volcanic structures that rise from its northern plains are the largest in the solar system. Olympus Mons, a shield volcano whose base would cover the entire state of Arizona, whose caldera sits at an altitude so extreme that it protrudes above most of the planet's thin atmosphere, is a feature that required hundreds of millions of years to accumulate. To stand at its base, if the mission trajectory and surface operations permit such a journey, would be to stand inside a duration so profound that the mind can only approximate it, can only gesture toward it with the imprecise instruments of metaphor and awe. The Valles Marineris, that vast canyon system stretching nearly a quarter of the way around the planet's equator, tells a different story, one of rupture, of the lithosphere pulled apart along ancient stress lines, of water that may once have pooled and flowed and eventually vanished into an atmosphere that itself gradually thinned and cooled and retreated. The evidence of that water is everywhere in the rock record. In the mineral signatures detected from orbit and confirmed by rovers that moved slowly across the rust-colored surface long before any human footprint marked it. In the layered sediments that speak of deposition, of accumulation, of time measured not in years, but in the patient stacking of material against material across geological epochs, so extended they seem less like history and more like a kind of geology of time itself. As though the planet has been keeping records in the only language available to something that has no voice and no memory in the human sense, the language of accumulation, of pressure, of the slow transformation of one state of matter into another across intervals that dwarf the entirety of human civilization, the way an ocean dwarfs a single drop of rain suspended momentarily above its surface before falling back into the hole. The crew will walk on this. They will place their boots on ground that has not been touched by anything living, perhaps, in billions of years. Perhaps not ever. The question of whether Mars once harbored life, microbial, ancient, hidden in the subsurface warmth near hydrothermal systems that may have persisted long after the surface grew cold and bare, is one of the genuine and luminous uncertainties that the mission carries with it. Not as a distraction from the practical work of survival and exploration, but as an undertone, a low and constant hum beneath every other frequency of the endeavor. Because the answer to that question is not merely scientific. It is philosophical in the deepest sense. It touches something so fundamental to the human understanding of what life is and where it belongs in the architecture of the universe that the implications, in either direction, are almost too large to hold. If life is found, even the ghost of it, even the chemical signature of something that once metabolized and replicated in the thin ancient warmth of a wetter world, then the universe becomes a different place than the one we thought we inhabited. Life becomes not an exception but a tendency. Not a miracle in the singular sense, but something closer to an inevitability, a property of matter under the right conditions, distributed across the cosmos in quantities and in places that the imagination can barely begin to populate. The loneliness of the human position in the universe contracts. Not disappears, but contracts, becomes something more nuanced and more companionable than the silence we have always feared it to be. And if nothing is found, if Mars is, and has always been, entirely and absolutely sterile, then that silence carries its own weight, its own particular and difficult beauty. Then Earth becomes more singular, more fragile. The improbability of what happened here, in this particular ocean, on this particular world, at this particular distance from this particular star, becomes more staggering rather than less. And the responsibility that falls from that improbability, the responsibility of being, so far as anyone can determine, the only things in the local universe that know the local universe exists, settles more heavily and more meaningfully on the species that has traveled across the void to ask the question. The crew will carry both possibilities with them as they work. As they core into the regolith with instruments designed to detect the faintest chemical whispers of biology past or present. As they move across the surface in suits that are themselves miniature life support systems, carrying the conditions necessary for human survival the way a snail carries its shell, not as luggage but as the prerequisite for the journey. The work will be slow. Mars does not offer its secrets quickly. The distances between sites of scientific interest are vast by the standards of any previous human exploration, and the terrain is uneven and occasionally treacherous in ways that orbital reconnaissance can anticipate but cannot fully predict. There will be mornings when the mission plan must be revised. When the weather, the Martian weather, the dust storms that can grow to encompass the entire planet and reduce visibility to near zero and cut solar power generation to fractions of its nominal capacity, imposes its own agenda on the careful schedules of the people who came so far to work within it. Dust is perhaps the defining material of Mars. Not the rock, not the thin cold air, not even the silence, but the dust, fine as talcum, electrostatically charged, capable of clinging to every surface it contacts with a persistence that the engineers who designed the mission equipment spent years attempting to account for. It coats solar panels. It infiltrates seals that were designed to exclude it. It gathers in the joints of equipment and in the fabric of suits and on the exterior of the habitat in a slow, continuous, almost meditative accumulation that is simply the planet asserting its own nature against the temporary presence of the things that have arrived from elsewhere. The crew will learn to regard the dust not as an adversary but as a condition. The way sailors learn to regard the sea, not as something to be overcome but as the medium through which all movement occurs, the substance in which all work is embedded, the thing that must be understood and respected and worked with rather than against. There will be rituals around the dust. Cleaning protocols performed with the patience of monastic practice. The inspection of seals and joints and filter systems that becomes, over time, as automatic as breathing and as necessary. The particular attention paid to the airlock transition, that threshold between the outside world and the interior one, where contamination is managed and suits are checked, and the invisible boundary between Mars and the small human version of not Mars is maintained with a care that is both practical and, in its way, ceremonial. Because the airlock is a kind of membrane, a place where two incompatible realities are held in careful adjacency, where the work of translation between them is performed daily and without fanfare, where the human body moves from one kind of world into another and back again with a regularity that eventually makes the extraordinary seem, if not ordinary, then at least navigable. This is what adaptation looks like from the inside. Not a dramatic transformation, but a gradual and almost imperceptible recalibration of what the mind registers as remarkable. The airlock stops being a threshold and becomes a door. The suits stop being instruments of survival and become, in the way that all necessary things eventually become, simply what one wears. And yet beneath that habituation, something else persists. Something that does not fully adapt, that retains its sensitivity across the entire duration of the mission, that continues to register the weight of where the crew is and what they are doing even as the surface routines grow familiar and the days accumulate into weeks and the weeks into months. It is not anxiety, exactly. Not wonder in the acute and breathless sense. It is something quieter than either of those things. A kind of background awareness, a low and continuous knowing, that sits beneath the practical layer of the day's work the way a deep current sits beneath the surface of water that appears, from above, to be almost still. The astronauts who have described this quality in their memoirs and in their recorded interviews reach for different words to name it. Some call it gratitude, which is close but perhaps not quite precise enough. Some call it humility, which touches the right register but tends to suggest a passivity that does not capture the active quality of what they are describing. One former long-duration crew member, reflecting on her time aboard the International Space Station, spoke of what she called a persistent aliveness, a sense that every cell of the body was continuously aware of its own improbable situation, aware in a way that people in ordinary circumstances access only occasionally and briefly, in moments of great beauty or great danger or great love. That the condition of being in space made this awareness not a peak experience but a baseline. The ordinary texture of a day spent at the edge of the possible. The Mars crew will know this feeling more deeply than any crew before them. Because the distance is greater and the isolation is more complete and the commitment is longer and the stakes, in both directions, are more absolute. They will know it on the surface, certainly. In those moments when the helmet visor frames a horizon that no human eye has ever scanned and the sky above it carries a color for which no entirely adequate word exists in any language, a blue-tinged violet at the limb that deepens toward a brownish rose at the zenith, shifting with the dust content of the atmosphere and the angle of a sun that is smaller here and colder and yet still, unmistakably, the same sun that rose over every morning of their previous lives. They will know it also in the interior moments. In the quiet of the habitat at the end of a long surface day, when the suits have been stowed and the data has been logged, and the meal has been eaten, and the small maintenance tasks that constitute the domestic life of the mission have been completed. In the particular quality of silence that settles over the crew in those hours, a silence that is not empty but textured, full of the ambient sounds of life support systems doing their continuous and essential work, full of the breathing and the small movements of people who have become, through proximity and necessity and the slow alchemy of shared difficulty, something closer to each other than most people on Earth will ever be to anyone. There is a quality of relationship that forms only under certain conditions. Conditions of sustained challenge, of genuine interdependence, of the kind of mutual reliance that goes beyond preference or affection into something more structural, the knowledge that the other people in the room are not merely companions but, in the most literal sense, the reason one is still alive. Antarctic expeditioners write about it. Cave divers who have spent extended periods in underground systems describe it. It is not always comfortable. People who are forced into radical intimacy by circumstance do not always like each other in the simple and uncomplicated way that the word friendship sometimes implies. But they know each other. They carry each other in a way that leaves permanent marks on the interior architecture of the self. The crew returning from Mars will carry each other this way for the rest of their lives. The shared experience will constitute a kind of country that only they have visited, a place with its own geography and its own weather and its own particular quality of light that cannot be fully translated into the language of people who were not there. This is not isolation. It is the opposite of isolation. It is the deepest form of communion available to social creatures operating at the boundary of what their species has ever attempted. The untranslatable shared thing that becomes, over time, the bedrock of a bond that ordinary circumstances simply do not produce. And the return, when it comes, the long transit back across the narrowing distance, back toward the planet that has been, for all this time, a blue and white point of light. Indistinguishable at first from any other star, growing slowly, incrementally, over weeks of approach, into something recognizable, something that triggers in the body a response that precedes thought, precedes language, precedes even conscious recognition. The return will be its own kind of reckoning. Not a homecoming in the simple sense, not the uncomplicated relief of return, but something more layered and more strange. The experience of arriving back at a place that has not changed and finding that the change is entirely interior, entirely yours, carried in the body and the mind, and the particular way the eyes now move across familiar things as though seeing them for the first time and the last time simultaneously. The Earth, from the window of the returning spacecraft, will grow the way all approached things grow. Slowly at first, imperceptibly, a brightening and a subtle expansion that requires patience to perceive, and then faster, the details emerging one by one from the resolved light, the blue deepening, the white of cloud systems becoming distinct, the green and brown of continents acquiring texture and specificity until the whole impossible beautiful fact of the planet assembles itself in the window like a memory becoming present, like something that was always known returning to the level of the felt. There will be a moment, somewhere in that approach, when one of the crew will simply stop what they are doing and look. Not with the analytical attention of a scientist or the trained observation of an astronaut, but with something prior to all of that, with the raw, unmediated attention of a creature recognizing home. And in that moment, the entire journey will be present simultaneously. The departure and the transit and the surface and the dust and the silence and the long interior work of meaning-making across the months of isolation. All of it gathered and held in the simple act of looking at the world that made them. The scientists and the mission planners will speak, in the years that follow, of what was learned. And much was learned. The geological surveys will take decades to fully analyze. The atmospheric data will refine models that reshape the understanding of planetary evolution across the solar system. The biological questions, answered in whatever direction they are answered, will reorient entire fields of inquiry. The engineering lessons of the mission will be folded into the designs of the next one, and the one after that, as the species slowly and incrementally extends the boundary of where it is capable of existing. This is how exploration has always worked. Not in single leaps, but in the patient accumulation of knowledge, each journey making the next one slightly more possible, slightly less lethal, slightly more within reach of the ordinary rather than the extraordinary. But there is something the data will not capture. Something that lives in the crew members themselves, in the changed quality of their attention, in the particular way they subsequently move through the world, with a slowness, a deliberateness, a tendency to pause at things that other people pass without noticing. The color of afternoon light on a concrete wall. The sound of rain. The weight of fruit in the hand. The face of someone loved, looked at with the full and unhurried attention of a person who has learned, in the most absolute environment available to human experience, what it costs to be alive and what it is worth. This is perhaps the truest thing the mission will bring back. Not the samples in their sealed containers, not the terabytes of recorded data, not the flags or the footprints or the photographs that will become, in time, as iconic as every previous image of human beings standing in places they were never supposed to reach. But the changed interiority of the people who went. The quiet revolution in their relationship to existence that no instrument was designed to measure and no report will adequately describe. The universe did not change when the crew landed on Mars. The distances remained what they were. The silence continued. The darkness between stars persisted in its absolute and indifferent completeness, unaltered by the small warm fact of human presence moving briefly through one corner of it. But something in the human understanding of that universe shifted. Something in the species' relationship to its own smallness and its own significance underwent a recalibration that will take generations to fully absorb. The way the light from a distant source takes time to arrive, takes time to cross the space between the thing that emitted it and the eye that finally receives it. We are still at the beginning of this. The Mars mission that feels, in the imagination, like a culmination is in the longer view merely an early step in a journey whose full extent cannot yet be seen. The solar system is vast and mostly unvisited. The stars beyond it are at distances that current technology cannot bridge within a human lifetime. And yet the direction is clear. Has always been clear, perhaps, from the first moment a human being looked up at the night sky and felt, beneath the fear and the awe, something that can only be described as recognition. As though the darkness were not foreign but familiar. As though the reaching toward it were not ambition but memory. As though the species has always known, in some register below language and below thought, that it belongs not only to this world but to the larger one that contains it. And so the crew sleeps, finally, in the returning vessel. The instruments maintain their quiet vigil. The earth grows in the window with the patience of all approaching things. And the darkness outside is the same darkness it has always been, ancient, enormous, indifferent, and somehow, in the way that only the most honest and most difficult things ever manage to become, deeply and permanently full.